Victor? The quiz will be at the end, or
yes,
no?
the quiz will be at the end. Let me wrap up the course, and then at the end we will have the quiz. Okay, there are only two small topics left. One of them is called R square adjusted, and before I go on to R square adjusted, I want to tell you what is the R square. R square is basically the variation explained by your regression in terms of SSR divided by the total variation. It can also be written as 1 minus the variation not explained by your regression divided by the total variation. It can be written in both ways, SSR over SST, and it can also be written as 1 minus SSE over SST, because SSR can be written as SST minus SSE. Now there is something that happens with R square in multiple linear regression. In multiple linear regression, you have, let us say, this y as a function of some variables. Let us say you have two variables on the right side. Now, let us say you want to include another third variable. Now, the thing is that when you include this third variable into the model, when you include it, regardless if x3 is a relevant variable or an irrelevant variable, R square will always increase. You may have a theoretically totally irrelevant predictor. You plug it into the model and you can see R square being increased. So when a new variable is entered into the model, R squared doesn't tell you the real picture whether the new variable was a good one or a bad one. Did the inclusion of new variable significantly improve the model or not? Because R squared does not have the capacity to decrease. Upon the inclusion of a predictor. We want a measure like R square such that if the newly added predictor, if it is a good one, R square should increase. If it is a bad one, R square should decrease. And that new measure is called R square adjusted. And this R square adjusted is nothing but a small adjustment to your R square, already existing R square. It is basically 1 minus SSE over SST. That is your R square. The only adjustment you make is you divide SSE by its degree of freedom. And you divide SST by its degree of freedom. And this new thing becomes R square adjusted. That's it. Now the beauty of this R square adjusted is that if the newly added variable is significant, R square adjusted will increase. If the newly added variable is insignificant, R square will decrease. R square adjusted will decrease. If you manipulate this formula a little bit, you'll be able to see that this is equal to 1 minus basically SS E over SST times n minus 1 over n minus k minus 1. And then you can write this one equal to 1 minus this SST over SSE over SST can be written as 1 minus R square n minus 1 over n minus k minus 1. This is the formula you will see in your formula sheet. To find the R square adjusted, basically the real formula is this, where you can see I made a little bit of adjustment, a very small adjustment, just to compensate the increased value of k. K is increased by 1, so we are compensating that. This R square adjusted is called the percentage of variation that is explained in Y by the predictors, comma, adjusted for sample size and number of predictors, k. Any question?
Doctor, shall we take the square root of the R?
No square root. No square root. It is always the positive thing. So before comma is basically R square, and if you add that comma after comma statement, it becomes R square adjusted. That was the first thing. That was the first remaining part of chapter 12. The second remaining part of chapter 12 is, suppose you have a model here, yi equals beta naught plus beta 1x 1i plus epsilon, where x1 is a predictor and x1 is a continuous predictor. Until this point, we have been assuming that x is a numerical predictor. We haven't discussed what happens if there is a categorical predictor. You can have a situation, for example, your y is grade 10 students heights, and x is height of their father. So obviously there is a relationship between grade 10 students' height and the height of their father. So who can tell me what is the sign of beta 1 hat do you expect? Will it be positive or negative? If I generate a data on these two variables and fit a simple linear regression model on the data, what do you expect? Do you expect beta 1 hat to be positive or negative? Faris?
Positive.
Why positive?
Because if the student's height increase, the father will be, if the father has a height increaser, the students will be also like that.
Yes, this way. The other way is not true. The thing that you were saying before, the other way is not true. If the student's height is big, that will not increase father's height. The other way is true. This is a one-way relationship. So you expect the slope to be positive in this question. You expect the correlation also to be positive in this this question. And just a side comment, in simple linear regression, the sign of correlation and the sign of slope, they are always same. If one of them is positive, the other one is also positive. Now in this situation, you have y as a function of x. Let me call this one as x1, height of the father. There can be another variable x2, gender of student. Males usually they have They are taller than the females. So if the student is a male, you expect him to be taller. If a student is female, you expect the student to be shorter than the males on average. Obviously, their height is related to their parents' height, specifically their father, but gender also plays an important role in the student's height. So if you plot the heights of students against their father's height, you might see this kind of pattern. You might see this kind of thing. Let us say this is x1, that is their father's height, and this is y, that is their own height. And you might see something like this. A bunch of students like this, and another bunch of students like this. Which ones are the green ones? Which one are the black one? Do you expect?
Males are green.
The males are green and the black ones seem to be females. So you expect this kind of bunch in your data. And when you fit a simple linear regression model, the model will be something like this. The model will pass from the center of these two data sets. It will represent nothing. It will neither represent the female nor represent the males. And there will be a big problem with the model. You will see the failure of assumptions and everything will be wrong with about this model. What will be the reason for this? The reason will be you are missing some important information on the right side of the model. What information? The gender of the student is playing a very important role here. You should not fit a single regression line in this situation. You should fit two separate regression lines in this situation. One for males like this, and one for females like this. The question is, how do you fit these two separate regression lines? The answer is you can separate out the data sets, one for male, one for female, fit two lines and give the user two lines, but it will look ugly if you give your user two separate models and ask him that if the student is male, go with this model. If it is female, go with this model. Because later I may ask, I may give you a categorical variable which has 4 categories, 5 categories, 10 categories. This one has only 2. So it's okay to give 2 models. Later, what if I give you a categorical variable that has 10 categories? Will you give 10 models to the user? That will look ugly. That will not look good. So we need a technique such that you give a single model to the user, and inside that single model, all the separate models are accommodated. Keep in mind, what we are doing here is we will fit 2 regression lines on this data, but we will give a single equation and both the regression lines will be accommodated inside that single model. And how are we going to do that? We are going to do that as follows. Your X2 is gender. Now, you write down what are the possible categories for the gender. There is male and there is female. There are only 2 categories. There can be more than 2 for different categorical variables. For example, a categorical variable can be color of eye. There can be multiple colors of eye. A categorical variable can be your section number or your instructor. Sometimes your grades are dependent upon the effort of the instructor. So different instructors can be your categorical variable. So what you will do is, number one, you will specify what are the possible categories of your categorical variable. Luckily for our categorical variable, there are only 2 possible categories. Now, out of these 2, you will specify one of them as the default, and it does not matter which one do you call as default. It does not matter which one do you call as default. If a categorical variable has 10 categories, you will call one of them as default, and you will forget about that one. Let me say I call female as default. So I will forget about the default category, and the remaining categories, I will introduce a dummy variable for all the remaining categories. And how will I introduce that? I will introduce it like this. I'll call it, let us say D1 equals 1 if student is male. And it is 0 otherwise. So now your data will be like this. There is Y student's height, let us say 62, 66, 69, 54, 57, 61, and so on. There is Y. Then there is X1, that is father's height. 61, let us say 69, 72, let us say 64, 67, 64, and so on. And then there is X2, whether the student is male or female. Let us say these are the values, and so on. So what you will do is you will define a dummy variable. I'll call it D2 for the convenience because it is corresponding to X2. You will define dummy variable D2. It will be 1 if the student is male. It will be 0 against all the other categories, And for your question, all the other categories are what? Just females. So this is your D2 now. Now this is how your data looks like. Once you have created the dummy variable, and keep in mind, other than default category, if you have 4 categories, then you will create 4 dummy variables exactly like this. And I will create it for you later. Once this is done, you just fit the model like this. Yi equals beta naught plus beta 1 x1 plus beta 2 d2 plus epsilon. That's it. You fit the model, and inside your model, you will get the model like this one. Yi hat equals 7 plus 1.1 times x1 plus let us say 2.4 times d2. This is your model. Now, how this single equation contains 2 models? Because inside this model you have D2, and how many values of D2 are possible? There is 0, there is 1. 1 indicates that the student is male. If D2 is 1, this model will be Yi equal 7 plus 1.1 times x1 plus 2.4. This will be 9.4 plus 1.1 times x1. And if D2 is 0, that is females, this model will be Yi hat equals 7 plus 1.1 times x1. So you can see that these are 2 models. There is one model, this one, and one here. There are 2 separate models inside a single equation. So I accommodated 2 models into a single equation using a dummy variable. A dummy variable is in terms of zeros and ones. Any question? Okay, in case there is no question, yes, Omar.
Yes, Doctor. What about if we have multiple category?
If you have multiple categories, this is what you will do. Let us say you have hair color as X2. And let us say your hair colors are black, brown, and white. Let us say you have 3 categories. What you will do is you will specify one of them as the default. Let us say black is default. Forget about the default one. You have 2 remaining, brown and white. So introduce 2 dummy variables, one for the brown. So call it D2. This is equal to 1 if the hair color is brown. 0 otherwise. For black and white, it will be 0. D2 will be 0. And you introduce D3. 1 if the hair color is white. 0 otherwise. 2 dummy variables are enough for explaining 3 categories. How? Because your data on hair color will be like this: black, black, brown, white, brown, and so on. So you will have D2 for brown. It will be 0 for other categories, 1 for brown. And D3 will be 1 for white and 0 for all the other categories. Now you can see if D2, D3 combination is 0, 0, 0, 0 means the default category. 0, 0 means default category. 1, 0 means brown. 0, 1 means white. So 2 dummy variables are enough to explain three categories. Muhammad Faris.
Can I convert it like to numerical and use for black 0 and for brown 1 and for white 2 in same column?
You are basically using how do I call it? Do you have the concept of scale of measurement? You're basically upscaling the variable, which is not recommended. Basically, what you are saying is that the black is 0, brown is 1, and white is 2. What you are saying is you are converting them into the number. When you convert something to a higher scale, that means the difference between 0 and 1 and difference between 1 and 2 using the properties of numbers. This difference is meaningful. OK, but here the difference between black and brown, the difference between white and black, this difference is not meaningful. When you are converting it to numbers, then you are saying that the difference between black and brown is equal to the difference between brown and white. So converting a categorical variable into the numbers, you can't use the numbers properties. There are different properties of numbers.
Yes, clear.
I don't know if you got my point or not. There is this property is linked with the scale of measurement. If you go to Google and search for the scale of measurement, you will get this point.
Okay, thank you.
Okay, gentlemen, turn on your Omar Adnan.
What about the equation? What will be?
The equation will be something like this: y I hat equals 7 plus 1.1 x1 plus 2 times d2 plus 3 times d3. Yes. So there will be 3 models. There will be 3 models inside this one. Which 3 models? One, when d2 is 0 and also d3 is 0, that will be a model for black. One, when d2 is 1 and d3 is 0, that will be the model for brown. And one, when d2 is 0 and d3 is 1, that will be the model for white. You will have 3 models inside.
That's clear.
Ahmad Ismail.
Doctor, we always use for the dummy value 0 and 1.
Yes, for the dummy variable, you always use 0 and 1. 0 means absence, 1 means presence.
Okay.
Okay, gentlemen, turn on the blackboard. I will answer to the remaining questions at the end of the class if needed. Now we'll go with the quiz. Turn on the blackboard and you will see quiz number 7. At this point, I want you to quickly turn on your camera. And those who have turned on their cameras, only they can start the quiz. I repeat, do not start the quiz. I'm going to tell you the password. Do not start the quiz until you turn on your camera. If I see anyone starting the quiz without turning on the camera, I will cancel the quiz. I will cancel his quiz. 0. Okay.